So here is one more classic problem at the screen. The famous wedge block problem, solved by using mechanical energy conservation and mechanical energy conservation and momentum conservation and some kinematic relationship. On the statement of the problem, you can see the figure, relate the statement of the problem with the figure. And the problem, the statement says a block of mass m, a small m, is placed on the upper part of a wedge of mass capital M, which can move without friction along the horizontal surface and released without an initial push. That means it is released from rest. What horizontal velocity does the wedge acquire by the time the block slides to the end? End, that means the lowest point. And what angle does the block velocity vector v makes with the horizontal if the angle at the base of the wedge is alpha? The height of the wedge is h. Neglect friction between the block and the surface of the wedge. So friction is completely absent. And many of you must have gone through this problem. And you know that the easiest way to answer the question is by using the law of conservation of momentum and energy. However, in this case, momentum, the conservation laws, basically the conservation laws alone are not enough. It is also necessary to use the kinematic relationship between the velocities of the wedge and the block. And that is why I am going to explain this problem. How should you think? I would suggest that I guess I should have a picture. Yes, there is a picture. You can see the first picture here. This picture. I would like to suggest that you consider the horizontal and vertical component of the block's velocity relative to the ground by Vx and Vy. Xy is x-axis is along horizontal and y-axis is along vertical. And I would like to suggest you strongly that you must denote the horizontal and vertical components of block's velocity relative to the ground by Vx and Vy, or whatever else you like to use. And so in this reference frame, the velocity of the wedge should be in this direction, so call it a minus v. Minus sign is because we have taken the positive x-axis towards right, so a minus sign before v would be sufficient to explain the thing that the wedge moves to the left when the block slides. And the horizontal component of the block's velocity relative to the wedge will be simply then relative to the wedge is Vx plus V. Horizontal velocity of the block relative to the wedge, not with respect to ground, will be simply Vx plus V. And vertical component remains the same because wedge has no velocity in vertical direction. So you can say, you can put this in your mind that the total velocity of the block relative to the wedge must be directed along its surface, this surface, along the surface of the wedge, and you would be able to write a kinematic equation like tan alpha is equal to, I'm working with respect to wedge, tan alpha equals Vy upon Vx plus V. This can be one of the equations you will be able to write. And if the velocity vector of the wedge with respect to ground, anywhere, though I have taken the beta here, that means the horizontal and velocity vector of the block बोथ आर, मतलब ये ब्लॉक की जो वेलोसिटी है विथ रिस्पेक्ट टू ग्राउंड ये हॉरिजॉन्टल के साथ बीटा एंगल बना रही है, तो ये विथ रिस्पेक्ट टू ग्राउंड है. सो दैट, तो इस केस में आप एक रिलेशन लिख सकते हो, ये बीटा अगर फाइंड आउट करने की ज़रूरत पड़ जाए तो tan बीटा इज सिंपली Vy अपॉन Vx. इस तरीके से काइनेमेटिक रिलेशन लिख सकते हो. एंड देन you have to consider the momentum conservation principle. अब ये काइनेमेटिक रिलेशन मैंने क्लियर कर दिए कि ऐसे आपको सोचना चाहिए. और उसके बाद डायनेमिक्स में आते हैं. तो हमें पता है प्रिंसिपल ऑफ कंजर्वेशन ऑफ मैकेनिक, ये मोमेंटम हम लोग यूज करना चाहेंगे. तो प्रिंसिपल ऑफ कंजर्वेशन ऑफ मोमेंटम यूज करने के लिए हमारे पास है, there are conditions, because all the external forces we have to consider the system, and system is given block plus wedge system, and all the external forces are missing in vertical direction on this wedge block system. What I just told, I wanted to tell you, forget it, I wanted to tell you that all the external forces on this block wedge system are acting in the vertical direction and missing in horizontal direction. So horizontal component of the system's momentum remains constant. इसका मतलब ये हुआ कि the center of mass of the system does not move in the horizontal direction because it was initially at rest. This is an extra statement. You can simply write the momentum conservation here and relate it with Vx. Vx is the velocity of block along the x axis, that is along the horizontal. So mvx should be equal to m into v, the velocity of the wedge. And this is the equation for momentum conservation. 1 के बाद मेरा ख्याल है 2 होना चाहिए और 2 के बाद ये 3 होना चाहिए. मैंने 4 लिख दिया था, 1 के बाद 3 लिखा था और उस समय मेरे दिमाग में 3 चल रहा होगा और ये 3 है. एंड tan बीटा tan अल्फा को आप किसी भी टाइम रिलेट कर सकते हैं. दोनों में कुछ न कुछ को कॉमन है, और जब कॉमन है तो उसको रिलेट करना किसी भी मैथमेटिक्स स्टूडेंट को पता होना चाहिए. एंड देन यू कैन राइट an equation for mechanical energy conservation. As you know, the initial mechanical energy was potential energy only, and that was mgh associated with the block, and at any moment this will be equal to the potential energy and kinetic energy of the system. And I think the question, in this question it was asked that what horizontal velocity does the wedge acquired by the time the block slides to the end. सो मैं इनिशियल और फाइनल पोजीशन को ही रिलेट करता हूँ, और ये Vx और Vy जो भी है वेलोसिटीज वो उसी मोमेंट पर के वेलोसिटी है, फाइनल मोमेंट पर के वेलोसिटी है. यस, तो मैं सब कुछ स्पिरिट में रखूँगा. तो mgh इनिशियल थी, तो अभी फाइनली जो है ना काइनेटिक एनर्जी इसका लिखना, the block's kinetic energy. Writing the block's kinetic energy is simple. Simply v under root vx square plus vy square is its complete velocity, and if you square them it will come out like this, and half is there, half mv square. This is the kinetic energy of the block, and you will need to write down the kinetic energy of the wedge as this. So these four equations, two kinematic equations, one momentum conservation equation in horizontal direction, and one mechanical energy conservation equation, and you can find anything what you want. This is the procedure to solve this kind of problems, and I usually follow this procedure, and if you like it, you can use it too. Thank you very much for watching.